Hello everyone. In this video, we are going to discuss the problem lexicographically smallest equivalent string from the Leetcode daily challenge. Here's the proof of correctness. Let's discuss the problem statement. You are given two strings of the same length s1 and s2 and a string base string. We say that s1 at I and s2 at I are equivalent characters. Let's see what does that mean. For example, if S1 equals ABC and S2 is equal to CDE, in that case A is equivalent to C. Similarly, B is equivalent to D, and likewise C is equivalent to E as well. Now let's see what equivalent characters mean. These follow the usual rules of any equivalence relation, which are reflexivity, which means that A is equal to A, symmetry, which means if A is equal to B, then B is also equal to A, and transitivity, where we can say that if A is equal to B and B is equal to C, then A is also equal to C. Our task is to return lexicographically smallest equivalent string of base string by using the equivalency information from S1 and S2. Now, for those of you who do not know what does lexicographically smallest equivalent string means, well, let's first discuss what this lexicographical order means. It basically means the dictionary order. For example, in a dictionary, AB is going to appear before BC. In that case, we can simply say that AB is lexicographically smaller than the string BC. Similarly, A is gonna appear before double A. That means that A is lexicographically smaller than double A. Now let's take an example to understand this even better. Let's say we have S1 equals to ABC and S2 equals to CDE, and we have our base string as EED. We have our base as EED. Now let's see what are our equivalence relations. In this case, we can clearly say that A is equivalent to C, similarly B is equivalent to D, and C is equivalent to E, which means A is equivalent to C, B is equivalent to D, and C is equivalent to E, which also means that A is equivalent to E. Therefore, our base string can be modified. It can be modified as um, C, C, D. Now D is also equivalent to B, so it can be made as CCB because C and E are equivalent. Similarly, A, B is also a possible outcome, and quite similarly, D is also a possible outcome. Or maybe we would not at all modify this thing. In that case, it is going to remain as EED. Now, quite clearly, there can be several more possible combinations, but let's see which one is going to be the lexicographically smallest modification for the string. Now, quite clearly, we know that if we want to make the lexicographically smallest possible equivalent of the base string, we need to replace each and every character with the smallest possible character. Now, by smallest possible, I mean that A is the smallest and Z is the largest character. Now, quite clearly, E is equivalent to A. So, we are going to replace that with A. Similarly, we are going to do it with the second E. Now, D is equivalent to B. Now, which is smaller? Obviously, B. Therefore, AAB is going to be our answer for this example. And we can see um, this fact in the problem statement as well. Now, in case you haven't tried this problem, link is in the description. Pause this video, go ahead and give it a shot. Also consider subscribing this channel for more such valuable and educational content. Now let's see how I was able to solve this problem. Let's consider the same example. For example, S1 is equal to ABC and S2 is equal to CDE. What I did was I created a map kind of structure, which means that A initially is equal to A, B initially is equal to B, C initially is equal to C, and so on till Z is equal to Z. Now, I also took the advantage that there are only and only 26 lowercase English alphabets, and it's quite clearly mentioned in the problem statement that we are gonna have only lowercase English letters. So I can quite clearly update these things in just 26 operations, just 26 operations, and S1 and S2 are going to be a maximum of length 1000, which means that 26k operations will be at max necessary, which they actually won't be, but at max we are gonna do these many operations in a very virtual scenario. Also, to modify the base string later, we will iterate the base string just once. So in case the base string has a length of m and s1 has a length of n, which is also equal to the s2's length as mentioned in the problem, in that case we are gonna make 26n plus m operations to solve this problem. Let's see how. So for example, S1 is equal to ABC and S2 is equal to CDE. What I do is that in this map kind of structure, I'm gonna each and every time update this right hand side values with the smallest character. So let's see how. If C is equivalent to A, in that case, I will replace all the occurrences in the right hand side of C with the letter A, which is going to be this in our case. Let's also write down D and E because they appear in our example. Similarly, when B and D are equivalent, in that case, I'm going to change the occurrence of D to B because whenever I encounter a D, I would like to print a B instead because that's what we discussed, right? Similarly, C is equivalent to E. Now I know that C is no longer an existent position, therefore I must update it with something. Now, how can we decide that? Yes, you are correct. We will simply change the value. We will simply get the value of C from our structure, which is equal to A. Therefore, we establish the relation that A is actually equivalent to E. Now, which one is smaller? Of course, A. Therefore, every occurrence of E on the right hand side will be replaced by A. And now I am going to simply iterate the string. Let's see what was our string. The string given to us was EED. And now we are going to simply iterate in our base string and modify it. The given string is EED in this example. So for example, now we can simply take the value of E as A. So that's going to be for the first two values, and D is now equivalent to B, which means that AAB is going to be our final answer. Let's see how does the code work. Here is the accepted solution. First of all, we are going to get a string from a function called getString. Now this getString function simply returns us a string that is A, B, C and so on till Z. Now let's see what does S do. S is gonna serve as the mapping function. For example, we all know that string is nothing but a vector or an array of characters. So 0th position is gonna correspond to A. Similarly, first position is going to correspond to B. Second will correspond to C and so on till Z. Now, what do you guys think that this position should be? Well, yes, you guessed it, or let's say you answered it correctly, and it's going to be 25 because it's zero-based indexing. Now we can simply consider the mapping that this integer 0 is actually equal to A, and similarly 2 will be equal to C and so on. So our getString function is a simple loop which is going to return us the string ABC and so on till Z. I also created a function called updateString which is going to update this string S. It's going to accept two characters A and B. A and B are equivalent. Now, first of all, I get the value of A. Remember that equivalence relation where we actually first had to get the value of C, which was equivalent to E, but C no longer existed in our right hand side values. So we will first get the value of A and similarly we'll get the value of B. Now if B is actually smaller, then I'm going to swap them and we will simply update the value at RHS. Wherever we encounter B, we will update it to A. Now let's see what do we do ahead. Now I store the length of S1 or S2, you can do any in a variable integer n. Now I update a loop and I update my string where S1 at I and S2 at I are equivalent and we update that in string S. Now as discussed, we simply loop inside our base string, update the current value as S at that character. Now remember that A is actually having a higher ASCII value, which is, I guess, the lower A has the value in 90s and the upper A has the value of 65. I think it's 97, but you guys comment that and tell me. Um, I don't exactly remember that because you can always write that. Anyway, we'll have to update it like this and then we can simply return the base string. Let's try to submit this code again and see if it gets accepted. As you can see clearly, it beats 100% in the time complexity and it beats 78% in the memory complexity, which is really great. Guys, like this video as a token of appreciation. Subscribe to this channel right now for more such beautiful educational content. Also, in case you have any query, then feel free to write a comment down and I'll be more than happy to answer it. Also, do not leave the question right now. Go ahead and code it. See you in the next one.